Which one of the following expressions is a square number for each positive integer n? So every single time it has to be a square number. One approach to this question would be to play around with every single algebraic expression and try to get a square, but 4 of them are not going to work. So you're going to spend quite a lot of time potentially trying to get a squared bracket which doesn't exist. So an absolutely valid idea and a good idea actually is to try some values of n and just see if it works, because we know it's true for each value n. If it fails once, then we know that one can't be the answer. So let's go with n equals 1. If we put it into a, we get 2, which is not a square number, so we can rule that one out. If we put it into b, we would get, it would be 1 times 2 plus 1, we'd get 3. Again, not a square number. For c, we'd get 1 times 2 times 3, so 6 plus 1 would get 7. For d, we'd get 1 times 2 times 3, that's 6, times 4, 24, plus 1, 25. Okay, that one is a square number. Now that doesn't mean that's the answer, it doesn't mean it's true for all values, it's just true for n equals 1. And then e, we've got 24, we'd then times by 5 to get 120, 121. So it's going to be either D or E, and they've both satisfied the first test. Okay, let's do a second test. Let's go with n equals 2. That's the second smallest number. Remember, as it gets bigger, it's going to make the multiplication more difficult. So we only need to check D and E now. Okay, let's do this carefully. So it's going to be 2 times 3 times 4 times 5 plus 1. And actually, 20, we did that one before, when n is 1 for E, in fact. So we're going to get 121. This one works again. If we put it into E, we'd do 2 times 3 times 4 times 5 times 6. So this was 120. I'm going to get 720 plus 1, 721. And that is not a square number. You could check and prove to yourself that it's not. You'd have to maybe think about the fact that 25 squared is 625. Then 26 is going to end in a 6, 26 squared. 27 squared is going to end in a 9, because the 7 squared, that gives us 49. 28 squared is going to end in a 4. There's no way, and 29 squared is definitely going to be too big. That's going to be quite close to 900, which is 30 squared. So we can definitely rule that one out. So the answer, just by process of elimination, has to be D. In the context of the SMC, we can just move on from here. But away from that, let's try and show that we definitely do always get a square number. Let's multiply the brackets out. So we'd multiply the first two to give n squared plus n, and the second two brackets to give n squared plus 5n plus 6, and then add 1 to that. That's going to give n to the 4 plus 5n to the 3 plus 6n squared plus n. Sorry, I think I made. Oh, sorry, that should have been made a little mistake there. Okay, sorted it out though. Plus 6n squared plus n cubed. So I've dealt with all of these. N cubed plus 5n squared plus 6n plus 1. That becomes n to the 4 plus 5n to the, 6n to the 3. Sorry, I'm rushing it. Again, we don't want to rush it because, make one mistake and it's all going to fall apart. Okay, we get this. Can we write this as something squared? Well, if we can, then we've got to have the same thing in these brackets. N squared and n squared, for example. Well, not for example, it has to be that to get n to the 4. We need a 1 and a 1 to get the 1. So it's all about the n term. Can we figure that out? Well, we're going to get the n squared term by doing that one times that and that one times that. And that gives us 6. That gives us 6n to the 3. So this must be 3n, because then I'll get, and this one must be 3n, then I'll get my 6n squared. And the same applies for getting 6n. We're going to do 3n times 1 and 3n times 1. And the 11n squared, if we want to check it, that's going to come from doing n squared times 1, the other n squared times 1 to give 2n squared, and then 3n times 3n to give 9n squared. So this checks out. We can write it as n squared plus 3n plus 1 squared. It is necessarily always a square number.